Hi, this is Dr. Shivnag Reddy, and today we are going to discuss about helium-neon laser and NDR laser. Laser stands for light amplification by stimulated emission of radiation. And here, whatever we are seeing, this is helium-neon laser. Now we will look into it, how it will work, and how the construction will be. And this one is first developed by Ali Javan and team. So as shown in a figure, this is the first developed one. First laser is ruby laser. Later, this helium neon laser is developed by Ali Javan team, and these members are here. And then we will move further. So basically, that helium neon will laser will be look like this. It contains a glass tube. Inside it, helium neon gas we will fill, and externally we will apply high voltage. Due to that gas discharge, there takes place a population inversion that leads to the emission of laser. So, just for idea, we will see how it will be. Right. So simply this practically this will be look like this, but whenever we draw in the on the paper the block diagram, it seems to be a simpler one. So this is the helium neon laser. So basically it is first developed by Ali Javan and a team, and this is a gas laser. Especially we will use helium neon gas in 10 is to 1 or 7 is to 1 ratio, and it is a continuous laser based on laser working style, whether that lasers may be continuous lasers or pulsed lasers. This one is a continuous laser, the 2-4 level laser system, and this block diagram shows for us. Now we will see how it will be constructed. Basically, it consists of a glass tube of 10 to 100 centimeters, means hardly 1 meter, and the diameter of the tube will be 2 to 10 mm. That's hardly 1 centimeter. And in that glass tube, we will fill with helium neon gases. And once we fill it, one side is a highly polished and silver coated. Its other side, it will partially polish, and we will insert two electrodes in order to provide electrical current for discharging these gases that leads to the population inversion. Right. Now, whatever we are here seeing, that is the energy level diagram. Basically, this helium neon laser consists of helium atoms and neon later atoms. Basically, helium atoms are more compared to neon atoms. So initially what happens, that helium absorbs the provided energy, and that helium atoms will get excited to higher level. Once they are coming down, they will release the energy. So in this process, these helium atoms will collide with the neon atoms and energy will be transferred. And in this neon atoms, we have different energy levels. Here we have Ne1, Ne2, 3, 4, 5, 6 energy levels are there. In that 6 energy levels, these are matching Ne1, Ne4, Ne6. These atoms will match these energy levels. So simply what happens, whenever we apply the external voltage, the electrical discharge will take place, and the helium atoms will absorb the energy and they will go to higher level. They cannot withstand there for higher time, so they will go down. Whenever they are coming to lower levels, they emit the energy. So whenever they emit the energy, in that process they will collide with the neon atoms and they will transfer their energy. So population inversion will takes place in neon. So once population inversion takes place, there is a transition of the atoms from higher energy level to lower energy levels by stimulated emission. So in this process, from Ne6, the atoms may come to Ne5 or Ne3, or maybe from Ne4 to Ne3, or maybe Ne1, like that. So in this process, whenever there is a transfer of the higher energy to lower energy, atoms is getting transferred, they emit the energy in the form of light. So based on the energy gap, we will get different types of the wavelengths. Here, this is a non-radiative So no energy, no light will be released, but energy will be released in the form of heat. So whenever comes, these three types of wavelengths will be released. These in the three wavelengths, what we required is this one, 632 nanometers, which is a red in color. So what we will do is we will use optical components which will absorb these two wavelengths. So by using a optical elements or optical components in the laser system, it will absorb these two and this laser will be emitted out. That is what we required in the helium-neon laser. Then once we get the helium-neon laser, what are the advantages? So basically this helium-neon laser emits the laser light in visible portion of the spectrum. So 630 nanometers range, that's a red in color. High stability and a low cost, easy to purchase. Then operates without damage at high temperatures. So whenever we are operating, there no not much temperature is released like a ND glaze. The limitations is efficiency is less, gain is less, and this is mostly used for low power tasks. This laser, helium neon laser. Then we will see what are the tasks. Basically, this helium neon laser will do. Barcode scanners, which are mostly used in our supermarket and grocery shops, and tool alignment in machineries, and non-contact measuring and monitoring purpose, blood analysis, particle counting, and alignment of high energy lasers like high power carbon dioxide or NDR lasers. Treatments also we will use in order to focus the beam or align the path of these lasers.